So liquid biopsies are a very promising tool for the clinic. However, there are some challenges regarding their analysis or the analysis of the biomarkers inside of them. So there's the characteristics of, for example, extracellular vesicles, but also there's analytical and also pre-analytical challenges. So blood is a very complex fluid, for example, and it can be quite difficult to extract the information that we are looking for from this blood. And one example of this is, for example, remaining platelets, lipoproteins that are still present in the plasma that can interfere with the downstream analysis and can actually hinder our analysis and our biomarker assays.
Extracellular vesicles being a really fascinating subject for clinical research and as a potential source of biomarkers has a challenge. And in the Nexus project, we are trying to solve this challenge by really enriching specifically certain extracellular vesicles which harbor biomarkers which were identified in the preliminary studies. The main aim of the Nexus is to evaluate, on the one hand, the Nexus technology, and on the other hand, the predefined biomarker panel for the diagnostic, detection and evaluation of the prostate cancer samples as blood samples from the liquid biopsy.
As the EV research field is maturing, we are realizing that the true potential for EV's diagnostic exploitation lies in their complex and dynamic biophysical and biochemical composition, which we can use in multiparametric analysis to get comprehensive real-time overview of the physiological and pathological processes. Nevertheless, aside from these opportunities, there are also certain challenges and requirements that we need to consider and which were presented during my talk. So to fully utilize the clinical potential of EVs, we still need to understand what is the amount of the available analytes, not just the number of EV particles, but also the number of biomarker molecules and their abundance relative to other contaminating particles and molecules in complex biofluid, how these biomarkers are distributed among individual vesicles, and finally how all of these factors combined translate to analytics that can help us to achieve sensitive, specific and fully quantitative EV analysis.
As the other speakers working on extracellular vesicle research as biomarkers indicated, the concentration of extracellular vesicles can vary quite a bit, and they can be very, very small number of particles in a milliliter of blood, or it could be large. So it is necessary to have technologies that can have a large dynamic range as well as very good sensitivity. As Richard Feynman said once, there is always more room at the bottom. What we're trying to do in our technology is to develop practical methods to detect individual molecules and biomarkers at minuscule concentrations. It's easier to do the higher concentration. We have a very large dynamic range, and we will enable liquid biopsies by addressing the need for detecting large variety of biomarkers at needed concentration sensitivities.
Extracellular vesicles from laboratory to IVD CE certified tests. So currently we are working mainly with EVs in the scientific laboratory, but getting them into the clinical laboratory Now, that's a whole different ballgame. To be in the clinical laboratory and actually being used, it means you have to be in vitro device certified in Europe, IVD-CE, and that means there's a whole bunch of different guides you have to follow, different certifications you have to get, and this was what I was talking about. What are the current problems? What do we have to address? What do we have to do? Where can we find the info how to do all of these things? And maybe there are still a few things in the scientific laboratory that we also have to think about before we can even head into the clinical practice.
In the framework of Nexus project, automation of processes is fundamental to increase the throughput of the platform and move towards industrialization. We successfully automated the isolation of extracellular vesicles from plasma samples, and we were able to reduce the overall timing of the experiment from more than 2 hours to only 20 minutes.
Despite extracellular vesicles, research holds an immense potential in different clinical fields, for example in diagnostic or for the developing or therapeutics. Their actual clinical translation nowadays is hampered by our lack of knowledge about EV's physicochemical properties, like for example the biomolecular corona. Biomolecular corona is a mesoscale phenomenon which occurs every time a nanoparticle is immersed in a biological fluid, where it is quickly covered and dissolved with all the biomolecules composing the biofluids. And this absorption then leads to a change and modification in the nanoparticle surface and biological identity, and in turn to dysfunction. And so we need new technologies and new techniques to study this dynamic phenomenon on extracellular vesicles in order to understand this phenomenon and to exploit specific features, and in order to favor the extracellular vesicle translation to clinic finally.
Not only the biology of extracellular vesicles needs a better comprehension, but also the technology related to extracellular vesicles needs further development. And this is where Nexus wants to focus its attention. In particular, within the project, we developed a novel strategy for using antibodies for separating and detecting extracellular vesicles. Because nowadays, techniques related to antibodies suffer of different disadvantages that cannot be overcome as it is. So within the project, we developed an aptamer antibody conjugate that is able to overcome this kind of limitation and can be used for the sequential separation and detection of extracellular vesicles, allowing their detection directly from biological fluids.